Welcome to the module on concrete technology. In this module, we will be discussing today the details about the fineness modulus. What is a fineness modulus? How the fineness modulus of the fine aggregates is impacting your concrete in terms of durability, in terms of strength, and in terms of the workability. What is a fineness modulus? The fineness modulus, commonly known as FM of the aggregates, is an empirical figure obtained by adding the total percentage of the samples of an aggregate retained on each of a specified set of series of sieves and then dividing the total sum by 100. The fineness modulus is a single number that is used to determine the distribution of the aggregate, how coarser the aggregates are, how finer the aggregates are. Depending upon the FM value, you can very well identify whether the distribution is on the coarser side or it is on the finer side. Lower the fineness modulus, smaller the average particle size, and larger the fineness modulus, larger is the average particle size. This is what is the indication of the FM value of aggregates in particular, and is equally in a position to identify in terms of the fine aggregates also. So how do we find the fineness modulus of aggregates? So in order to find the fineness modulus of aggregates, it is the set of sieves which is being involved in determining the size or the grading requirements of the aggregates, starting from 150 micron, then 300 microns, 600 microns, 1.18 millimeters, 2.36 millimeters, then 4.75 millimeters, 9.5 millimeters, 19 millimeters, 37.5 millimeters, and the larger sieves in the increasing ratio of 2:1. So what is required is you need to add the retained portion of the aggregates on each one of these sieves and then add them together. So that total divided by 100 will give you the fineness modulus of the aggregates. When we talk about fineness modulus of sand in particular, sand is generally graded between the sieve set of 10 millimeters to 150 microns. That is 150 microns, 300 microns, 600 microns, 1.18 millimeters, 2.36 millimeters, 4.75 millimeters, and theoretically 9.5 millimeters, or 10 millimeters when you consider specifically the IS 383 grading for zone 1, zone 2, zone 3, and zone 4 type of sand. Now what is being done is on each sieve the amount of or the portion of the aggregate retained is being measured and added to the next sieve. Like amount retained on 150 micron is x1, amount retained on 300 micron is x2, amount retained on 600 micron is x3, so on x4, x5, x6, and x7 in case of a 9.5 mm sieve retained. So the summation of x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x7 divided by 100 will give you the fineness modulus of the sand. What is the range of a fineness modulus? If you see, the same value of fineness modulus may therefore be obtained from several different particle size distributions in general. However, smaller values indicates the finer aggregates as being discussed earlier. When you see the range, the fine aggregates, the fineness modulus value ranges between 2 to 4. In case of a coarse aggregate that is smaller than 38.1 millimeter size, the FM value ranges between 6.75 to 8, and the combination of these two fine and coarse aggregates will always have an FN value intermediate between these values. When we see IS 383, the table 9 of IS 383, which designates generally the different zones of sand starting from zone 1, zone 2, zone 3, and zone 4. As we move from zone 1 to zone 4, the grading of sand, the particle size of the sand moves from coarser to finer. But IS 383 specification does not specify any limit for fineness modulus to be used in the concrete. It basically divides the sand in 4 zones as we discussed, right from zone 1 to zone 4. Zone 1 sand is being coarser and zone 4 is very fine in nature. It is generally recommended that grading zone 4 should not be used for reinforced concrete works unless tested for its suitability. Different ranges of fineness modulus as given in the international codes like ASTM, ASTO and USBR codes. If you see in ASTM C33 it is written that the fine aggregates shall have not more than 45% passing the sieves and retained on the next consecutive sieve, and its FM value will not be less than 2.3 and should not be more than 3.1. When we see the USBR codal provisions, the code specified that fineness modulus of sand shall not be less than 2.5 and it should not be more than 3. And when it comes to ASTO M6, it indicates that the fineness modulus of sand will not be less than 2.3 and it should not be more than 3.1 to be used for concrete works. Table shows the gradation limits given for fine aggregate, that is sand, in IS 383 2016. This is basically an extract of table 9 of IS 383 corresponding to the grading limits given for sand in terms of zone 1, zone 2, zone 3 and zone 4. The left hand table shows the upper limit and the lower limit of percentage passing from each sieve size corresponding to each zone of sand. Like for example, for 10 mm sieve, the percentage passing in zone 1 sand is 100. For 4.75, the percentage passing is between 90 to 100. For 2.36, the percentage passing is between 60 to 95. 1.18 sieves, the percentage passing is 30 to 70. And 600 micron, 300 micron or 150 micron correspondingly, the percentage passing is 15, 34, 5 to 20 or 0 to 10. Similarly, for each zone, the percentage passing is being captured as given in IS 383 of 2016 table 9. Now what is being done is on the right hand side you can see the replica of the same table which is being there on the left hand side, but the difference between these two tables is the left hand side table shows you the percentage passing, whereas the right hand side table is giving you the percentage retained on each sieve corresponding to each zone of sand. Like for example, if you see the zone 1, the percentage passing is 100% on 10 mm sieve, but the percentage retained is 0. Similarly, for 4.75 mm sieve, the percentage passing is 90 to 100, whereas the percentage retained is 10 to 0. 2.36 mm sieve, the percentage passing is 60 to 95 for zone 1, 60 to 95 for zone 1, but percentage retained is 40 and 5. Similarly, for 1.18 sieve size, for zone 1, percentage passing is 30 to 70, whereas percentage retained is 70 to 30. Like, how do you calculate the percentage retained? That is 100 minus percentage passing will give you the percentage retained straight away. So, the idea is you calculate the percentage retained for each zone of sand corresponding to each sieve size and tabulate it as shown in the table here. Now, in order to calculate the fineness modulus corresponding to each zone for representing the upper limit and the lower limit, what is being done is the fineness modulus is generally defined as the sum of the percentage retained on each sieve divided by 100. So this is the percentage retained on each sieve for a particular zone corresponding to, for a particular zone, that is zone 1 in this case, and the lower limit. So sum of this divided by 100 is corresponding to the value which is equal to 4. So the fineness modulus corresponding to the material which is matching with the lower limit of zone 1 will give you a value equal to 4. Similarly, for fineness modulus corresponding to zone 1, which is matching with the upper limits given in the grading requirement, will give you a fineness modulus of 2.71. That means for zone 1, the fineness modulus of the sand will vary between 2.71 to 4. For zone 2, the fineness modulus will vary between 2.11 and 3.37. For zone 3, the fineness modulus will range or vary between 1.8 to 2.78, and for zone 4, the fineness modulus will vary between 1.35 to 2.25. Now what is being done is we take the average of all these 4 values corresponding to zone 1, zone 2, zone 3 and zone 4. That means for a material to be in zone 1, the fineness modulus, the average fineness modulus should be around 3.4. For sand which is corresponding to zone 2, the average fineness modulus is 2.7. For zone 3, the average fineness modulus is 2.3, and for zone 4, the average fineness modulus is 1.18. That means if you see the IS 383 grading requirement, it indicates that your fineness modulus can range between 1.8 to 3.4 when you are considering the average fineness modulus of the sand, or else it will range between 1.35 to 4 when you are taking the individual limit, that is the upper limit and the lower limit given in IS 383 2016 table 9 grading requirements. That means values which are between the range of 1.8 to 3.4 are meeting the requirements or the criteria given in IS 383. But as if you check the ASTM or ASTO code, ASTM C33 in particular, it is clearly stated that the concrete requires a fineness modulus of 2.1 to 3.3 in order to be suitable for a concreting activity. That means anything ranging between 2.1 to 3.3 for the fineness modulus of sand, that particular sand is suitable for concreting, as per ASTM requirements. And if you see the IS 383 also, sand which is in zone 3, zone 1, zone 2 or zone 3 is generally suitable for concreting work, whereas we recommend that zone 4 sands are not good as far as the concreting activity is concerned. This can be utilized for other purposes but not for the concreting activity. So even though IS 383 doesn't give you a direct picture, direct limitation as far as the fineness modulus of the sand is concerned, but indirectly, if you want, you can calculate what should be the fineness modulus of the sand, which is suitable for concrete, even if the IS 383 is taken into consideration. But when it comes to IS 383, we know that IS 383 doesn't specify any value to the fineness modulus. It generally recommends that the use of code to use the sands of zone 1 to zone 3 for structural concrete works. But if you calculate the FM value for each zone which is being specified in IS 383 2016 table 9, you will be able to see that the zone 1 is having a range of FM value between 2.7 to 3.4. Zone 2 is having a range between 2.11 to 3.37. Zone 3 will have an FM value ranging between 1.8 to 2.78. And zone 4 will have a FM value ranging between 1.35 to 2.25. These values are for the lower limit and the upper limits being given in the grading table. But when it comes to the average value, like for average FM value for zone 1 is 3.4, average FM value for zone 2 is 2.7, average FM value for zone 3 is 2.3, and average FM value for zone 4 is 1.8. So when you see that the zone 3 is having an FM value, the average FM value around 2.3, and the maximum zone 1 will have an average FM value of 3.4, it is in line with the requirements given in ASTM or ASTO or USBR code, which specifies the lower and the upper limit of FM value to be in the range of 2.1 to 3.2. So directly not, but indirectly IS 383 also specifies the typical range of FM, which can be between 2.3 to 3.4 in particular. What is the importance of the fineness modulus? The grading and the maximum size of aggregate is important parameters in any concrete mixes. They affect the relative proportions in mix, workability, economy, porosity, and shrinkage of the concretes. Experience shows how the very fine sand or very coarse sands are objectionable. The former is an uneconomical and the latter gives a harsh mix. Means the coarser sands will give you a harsh mix, whereas the fine sands will become uneconomical because of the excess consumption of water. So if you divide the sand in three categories like fine, very fine, fine, medium and coarse sand, then you can see that the FM values for very fine sand is ranging between 2.2 to 2.6. For medium sand it is 2.6 to 2.9 and the coarse sand it is 2.9 to 3.2. So whenever you need a coarse sand to be used for a particular purpose, you should look for an FM value ranging between 2.9 to 3.2. And when you need a medium sand, generally for concrete, you will be looking at a range of 2.6 to 2.9 to get the optimum benefit of the FM or the distribution of the particles in terms of its compactibility, in terms of its void creation, and in terms of the movement or the workability. So generally the particle sizes which are ranging for these three types of sands are fine sand, the particle size is ranging between 0.4 to 2.075 millimeters, that is 75 microns. When it comes to medium sand, the particle sizes are ranging between 0.4 to 2 millimeters. And when it comes to coarse sand, the particle size is ranging between 2 to 4.75. Anything between 2 to 4.75 majority will give you a coarser sand. So the effect of grading of sand on concrete, if you see, grading or particle size distribution of sand affects the properties of concrete, like its packing density, the void content, the workability, and the strength part. Uniformly distributed mixtures generally lead to higher packing, resulting in concrete with higher density and less permeability and improved abrasion resistance, whereas uniform distributed mixtures requires less paste, thus decreasing the bleeding, creep, and shrinkage. If a fine aggregate is too coarse, it will produce bleeding, segregation, and harshness, and if it is too fine, it will demand higher water content. All of these factors affect the strength of the hardened concrete in particular. So it is important to understand that what is the optimum size or the optimum FM value which one should adopt in order to make its concrete more durable, it will have more strength, and it will give you a better finish in terms of the density, in terms of the permeability of the concrete, the workability, as well as the strength. So if you have a sand in particular, if you have a sand which is finer in nature, that means the FM value may be in the range of say around 1.3 to 1.5, which is definitely not suitable for concrete if it is being used as it is, because it falls under the zone 4 category if you see the IS 383, and under IS 383 2016 table 9, the note column, if you see the last note which is being given is, it is recommended that zone 4 sand should not be used for reinforced concrete until it is being checked for its suitability. That means when it is available sand is having a FM value which falls under the category of zone 4 or maybe a very finer material, then the best way is to increase the FM value of that particular sand or modify the FM value of that particular naturally available sand by adding the other final materials which is having a higher FM value. For example, if you have a FM value of 1.3, then by adding a crusher sand of 50 to 60% of zone 2 sand of 50 to 60%, you will be in a position to increase the FM value of 1.3 to around 2.6, which will be 2.4 to 2.6 range. Then this FM value, the sand which is having an FM value of 2.4 to 2.6, can be best utilized in concrete without any difficulties. So instead of rejecting the zone 4 sand right from the grassroots level directly 100%, you can utilize a portion of the lower FM sands and modify to increase the FM to the required limits or to the required values, and then use it for the concrete work. So to summarize this module, we talked about the definition of fineness modulus of sand and fineness modulus of aggregate, how the aggregate fineness modulus are ranging between 6 to 8 and the FM value for sand is ranging between 2 to 4. The calculation of fineness modulus of sand or aggregate in particular, the effect of fineness modulus of sand on concrete properties, and how to improve or modify the fineness modulus of the available sand, and how to make your finer sands more usable for concrete by improving its fineness modulus values